This is what differential execution is all about. Suppose you have a display here, for example, that you want to have content A, B, C, and F, G, provided that X and Y and not Z are true. Otherwise, we want to have D and E and F, G, and those can change at any time. So for instance, if you have event-based logic, you have to check for whether X or Y or Z changes and evaluate the Boolean expression and either hide A, B, C, show D and E, or move G, E up or down. If you have repaint logic, then all you got to do is have a statement that says if X and Y are not C is true, then we have A, B, and C. Otherwise, we have D and E, and in either case, we have F and G. This shows an example of a user interface written in this way. For example, all of these fields in here can appear or not appear. For instance, just by clicking the advanced button, we made these fields on the right appear, and all the buttons on the right moved to the right or left. All of this content is conditional upon features in the data. For instance, up here we have this method choice, and if we change the method choice, the fields can appear and disappear, and some of them can be quite a lot. And you can see all of this is very difficult to program if you don't have some sort of repaint logic, because there are too many things that have to be moved and made to appear and disappear. This is a quick stylized demonstration of how differential execution works. What we have here is a simple procedure that displays 4 buttons, buttons 1, 2, 3, and 4, and buttons 2 and 3 are conditional upon a Boolean here. Below this line, we're showing the state of the program. Here's the Boolean, which is currently false. There's a mode, and the mode has 3 values: show, update, and erase, which we're also going to show by colors, green, yellow, and red. X and Y are the locations where the next button will be placed. Below that is a FIFO, first in, first out, consisting of 2 halves, the old half and the new half. And let's start to execute the program now. We're in show mode, so that means whatever we do, we're going to show stuff. So we just showed the first button. The button primitive, what it did was to create the button and to write into the new portion of the FIFO the location and the width and height of the button. Now we're going to do the if statement, and the first thing we do going into and coming out of the if statement is to save the mode by pushing it on a stack. So we're going to save the mode, and now since the Boolean is false, we skipped over the contents of the if statement. So it didn't do anything, so it's going to pop out the mode back to show, and now it's going to do button 4. And by the way, notice that in passing the if statement, this 0 was written into the new portion of the FIFO. That's the value of the conditional. Now we're going to do button 4, and it's going to write its properties. Now at the end of the pass, before pass 2, we're going to copy the new portion of the FIFO into the old portion. And now we're going to change the mode to update, meaning we already have a display and we just want to update it. So now we execute button 1 in update mode, and what it does is to read its old position, width, and height out of the old portion of the FIFO, and it's going to write the new position and height, which happens to be the same. So it does nothing to the button. Now it's going to do the conditional statement, and now just by chance we've changed the Boolean to true, meaning it's going to have to do the inside, meaning creating buttons 2 and 3. Well, the way it detects that is by seeing that the button has changed to true. So if you notice here, just going back and forth over that statement, the Boolean has changed to true, and that tells the if statement to change the mode to show, which means it's going to show button 2 and it's going to show button 3, and notice their positions ended up down here. And now it's going to come out of the if statement, going back to update mode, and now it's going to do button 4. Button 4 is going to see that its old position is 0,9, its new position is 0,27, and so that tells it to move the button. And there it moved it. And that's the end of the second pass. You can see you can keep repeating these passes over and over. Here we're going to do pass 3, and in pass 3 we're also in update mode. We're going to update button 1. It does nothing. Its old properties were read from the old part of the FIFO and written to the new. Then we're going to do the if statement. But now notice that the value of the if statement has changed from true to false, meaning that the contents of the if statement are supposed to be erased. So it goes into erase mode for buttons 2 and 3. And button 2 reads its old properties from the FIFO, doesn't write anything new, and gets rid of button 2. Now it does the same for button 3. Now we come out of the if statement, and now we're going to update button 4. So button 4 has its current position is 0,27. Its new position would be 0,9. So as part of updating it, we move it. That's the end of pass 3. And so these update passes can be repeated over and over. Finally, to get rid of everything, we can do pass 4. We start out in erase mode. In erase mode, we're going to ignore these X and Y, but we're going to pay attention to what's in the old part of the FIFO. So here, button 1 says my old position is 0, 0. I'm going to erase myself. Then we get into the if statement, and the if statement is going to see that the old value of the Boolean is 0. See? That means skip over. Don't erase buttons 2 and 3 because they don't exist. So it skips over the if statement, comes back, and now it's going to do the same thing with button 4. And that's the end of pass 4. And so this whole process can be repeated over and over and over again. I hope you can see from this that this simple conditional can be expanded to all kinds of conditionals. If, else, we can use a while statement or a for statement. We can also put subroutines in here if they behave the same way, and the whole thing will continue to work.